Yeah, welcome to this presentation now. I'd like to give you, as you said, some insights regarding the test page that the ECI released at the end of last year. So the Altona test suite part 2, and it has another technical page. As those of you who are familiar with the old Altona test suite may know, there was one focusing on the ugly parts of overprinting, and this one is now focused on transparency. So what would I like to cover? It's 4 points: the purpose and the overall structure of that test page first, then some test results, just briefly looking at some, say, phenomena we saw when we tested pieces of it. As you will see, there are parts that you can look at separately. And what is the practical relevance at all? So is it just a test page for those sitting in a lab or inside of the engineering parts of companies? As we will see, there are issues, and as there are discussed already, where things do not behave as expected, as someone may expect. There's one big question: what is the right thing to do, or what is the right expectation? Because if you have confusing things, as we may see, then it's not clear which is the proper processing and which is just not. And last but not least, for the end user, it's very important to have a kind of conclusion whether or not PDFX4 is a good path forward instead of using the previous version, PDFX1A or X3. So let me start with the purpose and the overall structure of that page. It's all about PDFX4 compliance testing. So whether or not a system is able to process all the aspects that may come inside of a PDFX4 file. And there are some key aspects that have been introduced with PDFX4 that have not been there before. And as we have it as the major headline, transparency is the most important one, but there are some other properties as well, like optional content, also more commonly known as layers. There are additional picture formats like JPEG 2000. 8-bit is not the only one now which is supported as bit depth. It's also 16-bit images. We have open type fonts that may sit in a PDFX4 file. Smooth shades are not part of X4. They have been there already before. The reason for adding them on our test page was that it was not tested as thoroughly as it would have been good in the previous version of the Altona test suite. So we added some smooth shading tests, as we found out in the meantime that there are problems with some systems. And last but not least, ICC version 4 profiles have been introduced by X4. So the major focus is transparency, as this is the most ugly part in production that causes problems, be it transparency rendering or transparency flattening, which is widely used. So there are 2 versions available. They're available for download for free on the ECI webpage. One is where all the patches are available on a single page, on an A3 format page. And there's another one which is a multi-page PDF, where each page holds one patch so that you can focus on a specific property you want to test. We tried to simplify the evaluation of testing systems compared to the previous test page, where you had to read the documentation and compare documentation and test page results. In this case, we tried to do it in a more simpler way in terms of splitting each patch into sections, where one, as you will see in a minute, one section holds the properties to be tested, so it's live content, and the other section contains a image representing the expected correct proper result. And of course, there's documentation coming with it, explaining a little more about the background and the things to look at and what is the purpose of each separate patch. This is how the single page version looks like. So it won't get it doesn't deserve a design prize. Let me briefly introduce you to the different sections of it. We have 15 patches that contain if you want some day-to-day examples of design and prepress that may occur. So the basic idea behind this is that we found from the end user's perspective and from production areas that there are some issues in this and that area, especially at the time when we started some years ago with transparency flattening. We had issues with fonts, we had issues with this and that, so we collected examples that tested exactly these specific things. Then we have at the bottom of the page a very systematic part of patches which are meant to serve for two things. One is to get a better understanding of how transparency works. We learned it in the last presentation already. So we have 16 blend modes, and each of the 16 blend modes has one of the parts here. And there are some other aspects like we learned before, isolated groups and non-isolated groups. These are systematically used in here to get a better understanding on the one hand, and to have a better way of evaluating evaluate the processing of some system or software. And we have a gray frame around the page, which is, if it's properly rendered, a consistent gray. Nevertheless, it's divided in sections that have different color definitions, like black only, black with transparency, RGB and LAB. And if everything is properly processed, there is a consistent gray, although it's made of different colors. And last but not least, we have the label saying that it's the Altona Test Suite 2. And this one has two additional little items that you can see here, the lighter gray square and the darker one. And we named them color conversion indicators for the simple reason that one purpose may be to apply some color corrections, color conversions for whatever reason, which may have an impact on the visual appearance of that page, and to not force the people to watch all the patches, which one may be affected. There are these two things here that kind of alert if a color conversion was conducted. Because this is one of the issues that may occur along the workflow from the design or prepress stage of a file until the very end where it's in the output stage on a printing device or whatever. So this is the overall structure of it. Let me come back briefly. Oh.
Is this all CMYK based?
The page?
File?
No.
Okay.
It's all kinds of color definitions. So it's RGB in, there's CMYK, there's some device N, there's spot color in it, so almost everything, all the ugly things brought together on one page. All flavors. Yes.
You have a text error on that page, a bad one.
A bad one? Oh, I have one.
The Hebrew is backwards.
I'm sorry for that. So yeah, Olaf wanted to redo it, but yeah, it's for the next version we will make.
You have shalom backwards.
Okay.
Left to right as opposed to right to left.
I will have to make a note. Yes.
It's okay if it's at least the font's rendering it.
So the rendering is okay.
Consider this piecework.
Yes.
Yeah. Okay. So thank you for that hint. Just to explain that structure or that principle of evaluation of the split patches, you have a section to the left in this case, which holds the live content that is to be processed and then evaluated. And on the right-hand side in this case, we have the reference image that holds the to be expected result. So these reference images are always marked in the upper left and the lower right corner by these icons, just to make it easier for you to see which one is the reference image and which one is not. Because there are some other patches where the split goes not in the vertical direction, it's in the horizontal one. For design reasons, it would have been too complex to redo all the design. By the way, one issue with regard to the CMYK image, as you were asking before, there are different kinds of color definitions inside the live part. Why did we use a CMYK image then? Because of course there's a deviation if you have a spot color in it, in the live part, and you have a reference image which is CMYK only, then of course there will be a visual difference. The reason for us was simply that CMYK images are easier to render than a flattened version of the live content, which may contain overprinting. And if you have a reader that is not supporting overprinting, the reference image would be misguiding. So we wanted to use as a reference image something that is pretty easy to be processed and will match as close as possible with the live part properly rendered, which has in most cases CMYK parts. So RGB would have been the other option, but then we would have even more deviation in areas where there's none necessary. Just to give you a
So that's
glimpse.
interesting. That would naturally have been the reason I would have done CMYK images. Because what you haven't talked about yet.
Yeah.
This is a PDF X4 file
Yeah.
with its CMYK based output intent,
Yeah.
which means that everything on the page has to be rendered into a CMYK space.
Yeah.
So I would think that given that you're going to render to CMYK anyway, using CMYK images means your images are going to match. You don't
You're
have to do
right,
any
yeah.
color
Yeah.
conversion.
So it would be back and forth again. So
Right.
Yeah, sure. Yeah. Okay. So practical relevance and test results. Just some test results to have more time than for the uglier parts. Why is that page relevant? And it deals with different applications. And one application, of course, is output of a PDF X4 file in the printing area. And you have two ways. You have the one where you have a modern RIP, which supports live transparency, so then it's transparency rendering, versus the case where you have old, say, PostScript RIPs, which require some transparency flattening. So in both cases, the visual appearance has to be as designed, but it has to be tested. And both things can, of course, be done with the Altona test suite. Another thing is, processing PDF X4 files in some applications or production workflow environments. So starting with just importing or placing a PDFX, say an ad, on a page that is going to be printed somewhere else. So it's easy things like that, as well as processing PDFX4 files in a output environment where they are just imposed and trapped, and they may appear some color conversions. So depending on whatever you want to do, then the PDFX file is just a part of something else. And last but not least, it's to evaluate the software, which is widely used as being the reference implementation for what has to be the final output. And in this case, it's in the prepress area, of course. In the printing area, this application is just one. It's Acrobat X, a pro version of Acrobat. And
it's 9
Acrobat
today.
Yeah.
In
Switzerland, it's Acrobat 9.
In Germany, it's also 9.
Okay, maybe not in my case, but okay. There are good
Wouldn't make
reasons.
a difference in this.
If you have enough time and you may sit with Stefan, he has a bunch of good reasons for using which version of Acrobat. Sometimes it's 8, as I remember, where you said that this version is more reliable. But anyway, let's say it's the Acrobat Pro version that is used, and it has two features that are very interesting to look at in conjunction with transparencies. And one is the output preview, which in the past used to be the function that creates the most reliable representation on screen of what is to be expected. And the other one is transparency flattening, which is the feature, as you may know, that is used to do the flattening once the file has to be processed on a system that does not support live transparency. So these are some of the applications. You may have some others that can be in mind when you use the Altona test suite. And here's some results. Just, you may have much more of them side by side, looking at things that may or may not happen. In this case, it's one of the viewing, for those sitting in the back, it's this screenshot comes from the macOS preview. And as you can imagine, it's not as the designer intended, because this was the intended design, and this is what happened if the file was viewed with preview. Why is this important? In a professional area, people would not look at a PDF and say, this is what is the intention. This is what people do who might get for a final review a prepress file and then judge, is it okay to go to print or not? So it's very important to have in mind that it's not just professional software that is used, the highly ranked Acrobat and whatever. This is what may happen, and then people are of course confused. They will give the prepress guys the printer a ring and say, no, 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 you can't print it. And then the printer says, oh, it's looking okay, but they are looking on different things. So this is Acrobat, in this case just the reader, Adobe Reader, and in this case everything is fine. So it's confusing. Some other result, this is a patch Olaf did, so it's a pretty complex one. But what is wrong here, and you can see, for instance, the rectangles, this one is in front, although it should be behind the character, and there are some color issues. Also, the projector is not showing the proper color. You will see that it's not as it is intended or expected. So there are things that are simply not properly rendered in a way. Reader, again, in this case, does everything as expected. Some other results. Here we have, oh, really nice how these blends look. It's hard to be detected in the projection here. Maybe you see it now. He can see it better, the differences. But if you just come here. So what are the issues here? If you would look at it in macOS Preview, what you may do later on, some of the gradients differ from the reference. Not so clear here as it is if you look at it on another screen. Reader is doing pretty good on this one, but there's still a deviation in this area because there's something wrong. Particular one here is that these gradients are RGB, and there's something wrong with the sequence of rendering first and doing the color conversion later.
How do you create these white-side reference images?
Sorry?
How do you compose these white-side reference images?
How did we do this? Yeah, it was a tricky thing because first we simply used Acrobat because we relied on what Acrobat does, and so somewhere in the middle of our work we realized that as we had the confusing results, that sometimes Acrobat is maybe not right. So we had to as it will come in a minute, figure out which is the proper result, and then do tricks with InDesign and Acrobat and whatever to achieve a proper result. So it was not as easy as it seemed to be in the first place.
So what is the specification and determines the expected result?
Yeah, it will come in a minute. Maybe otherwise, please feel free to ask me again. Okay. You have a question?
I was just going to say, so what's render, so what is, I mean, I know some of the ones later on,
Yeah.
I understand, but like, what did you do on the gradients? What's rendering the official?
No. It was rendering first in RGB and then converted to CMYK. And what Acrobat does is it first does the color conversion and then renders, which gives a different color appearance. So it's a problem of these two steps. You have in the gradients, you have it's just a mathematical thing where you have the anchor points that are defined in RGB. And what Acrobat does is it first converts the RGB values to CMYK and then does the rendering of the calculation of the smooth shading.
Yes.
But the sequence should be around.
Why?
As it is in the spec. Just look at the spec. So it's a matter of the spec.
I'll take a look.
Yeah,
For
yeah.
smooth shades, it seems, I mean, there is a reason why we do the conversion first. I'll go look to see that if
Because it's
it's.
easier.
What's that?
It's easier.
Well, no, that no. It's not actually. It's actually not easier. But what it does is it gives you better results. It gives more, especially if the destination is CMYK. What you get is a more accurate result. This is also even more true if you're going to press.
But if you take this one and look at it and not out in this projection,
Yeah, I'll look at it.
but then it's much more vivid and much more Yeah, it's
You
better
did it on
in view.
screen, but if you were to output
Yes,
this.
of course, nevertheless, it's better. It's
Yeah, it's better, that's what I'm saying, that's a perfect example of, on screen it might look better, the order you're talking about, but actually on print
Yes,
device,
also,
it'll look better.
also. No, yeah, because you see, later on it is, in this case it is already CMYK, but the conversion result of both the blending itself and the color conversion gives a pretty dull result here, pretty flat compared to what happens if it is done in the sequence as we expected from the spec. Sure. So it was one of the points, what I should have mentioned before. While we did that test, we had a beta phase of 1.5 years where all Adobe and all others were invited to share with us their ideas and do tests with the preliminary version of this test page. And one of the participating companies doing color conversion, they gave us that point and said, oh, there's something wrong, obviously, in our reference images. So first I used this part of the reference image here, and then they said, oh, your reference image is wrong. Then we went back to the specification and saw, okay, we have to first render the single shading and then do the color conversion, and this is what comes out then. Okay, so there are some issues that are a little confusing. Some other one here. This is about, we have a section here which is with spot color, and then one that is process color, which has different ways of achieving the identical visual appearance. And as you can see here, some of these technical implementations and how it may be sitting inside the PDF are processed properly, and some others are not. So here is maybe an overprint issue. If you look into it deeper, then you will see the differences or the reasons what goes wrong. But again, if it's done properly, everything is consistent. This, for whatever reason, things may be implemented in a PDF file in all these flavors. It may be on purpose by the prepress guys or the designer, or it may just happen because the software creating the PDF is doing it this way or that way. But of course it should be rendered perfectly, and then it should be consistent. So here it is okay. Another one of these ugly parts at the bottom, as I said, the systematical testing of blending. This is the expected result. In this case, you have on the left-hand side the live section, and on the right-hand side mirrored the reference image. And as you can see, it should be consistent, but what comes out of preview or accurate reader is different. It differs, so it does not behave as expected. So this is one thing. There are differences between the applications. There's another one that was, at least for us when we did the test page, more confusing, is if there are differences within the one software. And this is what we get from that part at the bottom in Acrobat 10 with output preview on. So this is the result, just look at it. And it predicts what is to be expected if it comes to an output with a Adobe PDF print engine as the system preparing the output on print, doing live transparency and render it without flattening. And this is what comes out of flattener preview, which is not the same. And this, of course, is confusing. We have a design which is for good reasons and has to be output on a system which supports live transparency, and another one that does not, but the result should be identical, and it is not. So this is a very confusing thing for those doing that job, and this was a situation we had to face then.
So you ran the flatteners, the one on the right,
Yeah.
as the result of running the flattener.
Yeah, this the result of running the flattener, and then you get this result.
Right, because the flattener doesn't take into account the flattener does not consider that it's a PDFX file and take into account the output intent colorants because the fact of the matter is that we at that moment we don't consider it or have not historically considered it relevant as part of the flattening process. Now,
Okay.
whether we should or not is a different thing because But that's why the flattening process is the results of flattening are generating a very different color result than what you're getting out in the regular render, because there's no consideration for PDFX. It's also the same reason why, you and I talked about this a bit last night, it's also why output preview on is different than output preview off. Because in output preview off, we implement exactly according to the PDFX, all of the X's, spec. When output preview goes on, as you said, which is right, we try to match closer to what is expected on print, and the default mode of Monza, the PDF, of the Adobe PDF rip, is not to operate in PDFX compliant mode. That's the way we ship it to our OEMs by default, because that historically has been what our OEMs have requested. Now, I'm not saying that's right, I'm just saying that
That's the reason for the things.
There's consistent behavior by design, which may or may not be right.
Yeah.
Right, which is why I say to people, at least today, if you want to see what it's going to look like exactly according to spec, use default rendering. That's what we did, which is different than what we do in the other modes. Clearly, we need to reevaluate, and we've already been going down this process of what is the right thing to do in these other options vis-a-vis the PDFX and also PDFA and other standards. What is the right thing for us to be doing out of the box?
Just for us, or for the end user, it was always, if you want to judge a file, switch output preview on, and then you will see what is to be expected. And as you explained it right now, the outcome is vice versa. So it would be better to switch it off to see what comes out. And this is confusing for all those people who learned for years that switch on output preview.
Yeah, either that or more than likely what we're going to do is we'll correct output preview to match, basically, and this has always been my opinion anyway, when you bring up output preview, it shouldn't change, at least for a PDFX file.
Yeah, and it should be properly processing everything of a PDFX4 file and all the rules that sit inside that file. Because you want to do some other things that output preview is very good on, switching on and off channels and so forth.
Exactly.
So you need it for that output part, but it should not behave like this one here, which does it for historical reasons.
Exactly.
So the kind of intermediate conclusion for us was, while we were working on that test page, we saw, as you saw it here, some confusing results. Different applications produce different results, and it was not clear to us which, if any, of these applications produces the right outcome. So it was not easy for the practical thing to create the reference images to pick one application and say this one is the right one. The other thing was the inconsistency I just showed you from Acrobat, where the very same application produces different results of the very same design. So for us, that means the conclusion was we had to do some further investigation to see what is the to be expected result and what has to be the proper processing. And as a first analysis, we saw that we had many findings. Let's name them findings in that phrase and not just errors or faults. We had some surprising differences between what we expected and what came out of as the result. These are the findings in our terms. And we saw that in many cases where we had findings, there was color management involved. So in this case, what you see here are objects on that page that are colored in RGB or LAB, and some of the patches you saw before had errors, like the characters here, or in this case, it was exactly these smooth shadings that were not properly rendered. So there seems to be something in conjunction of transparency on the one hand and color conversions needed to process that transparency properly. So that was that intermediate thing. So next step. Who defines the proper rendering and proper processing? And what are the standards and the technical specifications? And the first step is quite easy. We have two papers. And these are, on the one hand, the ISO 15930 Part 7, which is dealing with PDFX4. So as we are testing compliance of PDFX4. And there's a clear reference that this ISO standard is based on the Adobe specification of PDF 1.6. So it's at that part not ISO 32000. It's to be precise, if you want to check things, how they are implemented, then you have to go back and use the Adobe specification. So the PDF reference, as you can see it here, for the format version 1.6. This is one thing, and as we learned from our intermediate results, that color management is a very important thing. It is worth to look at those issues a minute. Without transparency, color management is ugly enough, but it's comparable simple, because it's just the question to take some object from its source color space to the destination, or printing the output color space, taking into account things like rendering intents and so forth, but it's just one color conversion that is needed to come from an object, which may be RGB, to the destination, which may be some printer. With transparencies, the complexity is raised, because we have as we learned before, that the blending, the calculation of that result is to be conducted in the so-called blending color space. What does that mean? It means that if the backdrop, so the background element and or the source element are not already defined in this blending color space, that there is a need to convert them to this blending space first, prior to do the calculation that we learned before is just a mathematical thing. So there is this additional color conversion needed prior to do the transparency calculation. And last but not least, that blending result may be in a color space that is not the one of the output device. So there are several reasons why this may happen. It may be not a good idea, but it may happen for different reasons. If people collect things and put them on a page, it's not necessarily everything defined color-wise in the output space. So if that blending space is different to the output space, then there's another color conversion needed. So with these things in mind, we had to go through all the conversions to create the reference images, and this is what you have to do if you want to implement that transparency rendering and processing.
So you and I talked about this a little bit last night.
Yep.
Go back to that slide.
Yeah.
So the fact is that with respect to the blending color spaces,
Yeah.
the spec is actually slightly ambiguous. And that if you have an object inside of a transparency group with an explicit blending space, but that object is itself not directly involved in a transparency operation, it is ambiguous whether or not that object needs to be converted to the blending space.
Oh, I wouldn't say, no, we talked about this yesterday, and I think we have two views on this. I think in the spec it's clearly said that all the objects that sit in the group, which is a part of the stream, then it has to be converted.
No, so the actual wording, so the wording of the spec, because we're dealing with this, is when necessary, is the relevant phrase. And so the question, and this is the ambiguity is what defines necessity? So when is it necessary? And I agree with you that the traditional version of that reading, and certainly the easy way to implement such, is to just convert the entire object.
Yeah.
But the fact of the matter is that there are cases where it's not necessary, nor is it actually useful to do so. And so it is a valid implementation according to the spec to not, while what you described is perfectly valid, perfectly reasonable, and the common implementation, there is another way to read that portion of the spec which is also valid.
Yeah. But I'm referring to another part of the documentation. I could figure it out where it is later in the coffee break or so, where it says not about necessary or not necessary, where it really says all objects that sit in this transparency group have to be converted. regardless whether they are affected by the transparency because they sit aside or not, then they have to be converted.
Now,
I can show you
Go
that
ahead,
part.
because both, believe me, I went
Yeah, let's
through
do this later.
It says if, in both cases, the word necessary is present, but we can.
Oh, we can go through this later. Yeah, okay.
Is this the 1.6 spec or the PDF?
This is 32,000, but I can actually tell you that those words go all the way back to 1999, when the original transparency spec was first put together by Adobe. So it's, those words are unchanged from the version before it was ever sent out to the public. From the internal Adobe version until 32,000-1, those paragraphs are unchanged.
But it would
Other than like normative shalls to shoulds.
But it would agree that if it comes to the page where we have the synthetic patches at the bottom of the page, where the overlap is and where the object is affected by transparency, all this applies.
No question at all.
Okay.
Absolutely no argument.
Okay, good. So complex task, not to go through all the things here, just to figure out, as I said, the blending space seems to be very important. Which one is the one to be taken? It's too small written here to read it. You may have downloaded the presentation. What's it about here? We have a blending space where all the calculations have to be conducted that create the result of the transparency. And which one to take is not is depending on some other aspects of that PDF page. It is whether that object sits in the objects are part of an isolated transparency group. Then, and if this one has an own blending space, then this blending space has to be taken. If it's not, but it's part of there is a parent transparency group which has its own blending space, only isolated groups may have this, then this blending space has to be taken. It may come from the page group, as we learned before. There is the page itself is also a transparency group which may have its own blending space. And if none of this applies, then it is in the PDFX4 case the color space of the output intent profile. So we have 4 versions, and it's not so easy for you doing the evaluation which one to take. So there may be some further investigation, not just of the group where the transparency has to be conducted, but also to look at the parts that are around it. So it's not so easy.
And just a reminder that that's also not just PDFX, but that also applies to PDF A2 and to PDF E1 as well, with regard to the standard, same model.
Yeah. And it may have big impact on the result of some blending effect. So it may then be very critical with regard to the consistency of the content, not just a visual effect. It may be whether or not you can read something or not can, or if you cannot read it. So as a good point that you made, it's really for archiving and so forth, where the content itself, be it a number, can be read or not. And if some struggle is before court, that somebody says, I was not able to read that paragraph, and the other says, yes, I was able, then it is very, very important to have a consistent result. So, partial positive conclusion that we made along the work on that page. One thing that works pretty well is the kind of PDFX1 plus live transparency. So in the print production world, so the professional ones doing offset and so forth, PDFX1, which means CMYK and spot color only, without any color management of RGB and so forth, is the reliable basis. But what these people want is to get rid of problems with transparency flattening, which may occur with all the anti-aliasing lines and all the other stuff that may happen. So they can be happy that today's implementations, at least the high-end ones, work very well. So it works if no color management is needed. But how about transparency and color management is involved? And for this case, I would like to give you one example that is of maybe more of interest in your area, transpromo printing. And what you see here is, or what you see in a way in this projection, is a kind of bill that is printed from a system, and there's an ad that should be placed on that bill. So transactional printing or transpromo printing. So the intended result, of course, is that both look as intended. So the bill should be readable, and that design should look like it is designed here. And just some object properties with regard to color and transparency. We have an ICC-based RGB image in the background, which is not a bad idea once you do not know in which output that image will be used. So you leave it up for a later stage to do the best possible color conversion. For that reason, people may use, and do use in practice, an RGB image, while the circles here are created in CMYK. So to speak it in clear definition, it's device CMYK, which happens to be just black, so no cyan, no magenta, no yellow, just 66% in this case black. And blend mode that was taken is color dodge. It creates that effect you may see here. It depends on the background whether or not the circles are visible or not. So it's just an interesting effect the designer happens to choose. What is the result of today's implementations? And the asterisk says that in this case it is what you see in Acrobat X, or what you have to expect from systems which have inside the PDF print engine, the actual print engine. And as you have said before, maybe it came from the discussions, it's not necessarily what Adobe says what happens, what has to be the outcome, it's how the OEM partners implement the Adobe PDF print engine. But what you will see now is what happens in today's implementations. This is the expected result, of course. You see all the circles, everything is fine. The color is not very good here due to the projection. This is what happens if you use these systems. And what you may see, I hope you can see it, although it's at the bottom here. Otherwise, just look at the presentation when you download it. The circles are almost gone. And the color of that image is even more flat. It's like brownish, reddish, whatever. It's not as intended.
How did you deposit the ad into the document?
Sorry?
How did you put the ad into the document?
It's using tools that are used to do imposition and whatever, where this ad is placed, and this is the technical reason for that effect, as an isolated group.
With which color, with what blending space?
The blending space is device CMYK.
And this is a PDFX file you
Yeah.
generated?
Yeah.
So it's an exposition.
Yeah. And then things like, and exactly this happens, and device CMYK, if you look at it from a technical perspective, you will see what happens there. But from the end user perspective, it's useless. You can't use this thing here, so you can't. You have to. You would risk, if you would do it that way, which is a proper way, that things like that happen.
So the left-hand side is the normal view of the output?
No. This is the expected result, and this is what comes out just by placing that ad as an isolated group.
What comes out where?
Wait a minute. What was it before then? Are you saying that on the expected according to what rules? I mean, what was
Here
the,
let me go back. So, no. This one, even if it is an isolated group, works. But if it's placed, no.
oh wait, so it's an isolated, so if that's isolated, you said if it's isolated CMYK in the final output, you get the circles.
CMYK, yeah, the same CMYK.
But if I isolate it as device RGB, what do I get? So you're rendering
No. It's a CMYK output, and what happens is, so things that we discussed up front, that the conversion to this blending space device CMYK is in your implementation undefined and runs in a very straightforward, simple way, getting rid of the black component, causing in a separated blend, there are separable blend modes, we learned it before, where all the channels are calculated channel by channel, and as this RGB image is converted without a black channel, and the circles are black, the end of this is that the circles are gone.
Okay, so what rendered? I'm still missing.
You're still missing something. Okay.
I still don't understand what. So when you render this,
Yes.
you have to have. There has to be some blending space.
The blending space is device CMYK because it's an isolated group.
Right now, you're using device CMYK as the blending space to render that image.
So it's a piece. I can give you all the pieces.
No, I understand, but right. But I'm just asking you. You rendered that in CMYK as the blend space. On that was rendered in CMYK.
Yeah.
If you place that as an isolated CMYK,
Yes.
you should get the exact same result.
Yes, exactly. This is what I showed you. This is the expected result. But just
Yeah.
for that switch from not isolated group to isolated group, the behavior of Acrobat is completely different.
Well, what's the page blend?
The page is a
Oh, wait, was that an output preview or regular render?
that was with output preview, and it
That's
was
okay,
what
fine,
happens.
fine.
Yeah.
Yes, so with output preview, that is correct.
And
That's
what-
why I was
and what
doing that. I thought
systems-
that was the regular render.
Ah, okay.
That
No,
was
no,
my
no, no.
mistake. Because regular render, you should see the right thing.
Yes,
Regular render looks
but
correct.
you know the implementation is on those.
But you're running out of time. But go ahead.
Okay, I think we have to stop also.
Yeah, that was what that was.
But before you said that the output preview is corresponding to what the print engine is doing.
Correct.
So, but in this case, this is two different results. That's why I asked before, is it output preview or normal view?
Right, so
Output
he's,
preview.
so he's,
Output preview and what systems using the Adobe PDF Print Engine 2.5 in their implementation would produce.
That means
So this is
output preview does not represent the
no,
print engine.
No.
no, he's saying
This
that
comes out.
that's from output preview. The one
Yeah.
on the right is output preview,
I
which
thought that was
also,
print engine.
which is which should be
The same thing. Yeah.
Okay.
Right.
But this, to the right is output preview and
And
the
the
left
left
is...
would be normal render.
Ah, okay. I misunderstood. I thought this was
Yeah.
output preview versus real
No.
printout.
Yeah, but the problem is really that this is what you will get on from the press, so
Yes.
from the printing
Yeah,
press.
but you see that in output preview already.
Yeah.
Correct, which
Okay.
is because that's today.
Yeah.
So that's good and bad. It's working the way it's supposed to work,
Yeah.
which is not necessarily
Okay,
the right.
That means urgent request that Adobe should push its OEMs to implement PDFX finally
Well, so-
after 10 years.
Well, so there's a number of interesting questions that this raises, and
Yeah,
we
and I
we're
think-
going into a break,
yeah,
so we
yeah,
should really,
exactly.
you go ahead and wrap up.
So
and
like,
talk about
it's
this
just
later.
the last slide or so, or the last two slides. So what is the status quo from the end user's perspective? We have, as we learned before, some suboptimal implementations, be it bugs, be it inconsistent behavior, be it the thing that we just looked at, that the change of a specific property changes the overall appearance of some piece of artwork. So, and there are obviously different opinions of right and wrong once it comes to the discussions around the specification and what vendors do and what the ECI expected. So what we hope from the end user's perspective is that vendors provide consistent implementations that are suitable for day-to-day design and production tasks. So this is just to say it in brief what I hope for that will come from all you in the room doing, providing solutions, and mainly from Adobe, of course, because you are the reference. So thank you very much for your attention, and yeah.